Welcome. So in this video we will learn about the procedure, reactions involved, calculations and principle of determining the free fatty acid value of ghee. Now acidity or free fatty acid content of a fat is normally a measure of the extent to which hydrolysis has liberated the fatty acids from their ester linkage with the parent triglyceride molecule. So we know that during hydrolysis hydrolytic reactivity takes place in which the triglyceride glycerol is acted upon by the lipase in the presence of moisture, and also temperature also is having the catalytic effect for this reaction. We'll have the glycerol formation and the free fatty acid formation. So these fatty acids are free from the fat, that is why they are called as free fatty acid. And partly for this reason, acidity of ghee is extensively quoted as free fatty acid percentage free fatty acid content expressed as oleic acid. So only percentage free fatty acid content in ghee is generally expressed as percentage oleic acid, because oleic acid is the major unsaturated fatty acid of ghee and is also the major contributing acid towards the acidity of ghee. Now free fatty acid content of fresh ghee varies from 0.09 to 0.20% with an average of 0.15%. Now unacidic quality of ghee deteriorates with increase in the free fatty acid content. So free fatty acids impart bad volatile odor to the sample, so thereby deteriorating the sensory quality. And as per FSSAI rules 2011, ghee should not have free fatty acid content more than 2%. So this is the recent FSSAI standards. Ghee should not have free fatty acid content more than 2%. Now level of acidity shows the presence of fat to oxidation. So once the free fatty acid are produced, they are prone to oxidation. So free fatty acids are majorly indicate the hydrolytic rancidity, but also the oxidative rancidity also. So highly acidic ghee shows faster oxidation and has poor keeping quality. So with increase in acidity, there is decrease in the consumer acceptability also, because the sensory quality is affected. So again, the reaction which is happening by this is the hydrolytic rancidity, that hydrolysis, that lipase act on triglyceride in the presence of moisture or temperature, and we'll have the glycerol and the free fatty acid formation. Now a principle involved is that free fatty acid present in milk fat products is estimated by acid-base titration. So we are doing the acid-base titration with alkali sodium hydroxide, 0.1 normal sodium hydroxide we use, using phenolphthalein as an indicator, and endpoint comes at around pH 8.3, and the free fatty acid content is present at percentage oleic acid. So we are titrating during the titration reaction involved in that fatty acid which are free fatty acid present, which are present in the sample. It will react with the sodium hydroxide that is used as titrant, and then we have the sodium salt of the fatty acid, and then we have the water molecule that is released. So this is the reaction which is happening during the titration. So what is the procedure? So you have to take 10 gram of milk fat sample in a 250 ml conical flask, and then in another flask you add 50 ml of the ethanol to the boiling point, and while still above 70 degrees Celsius, neutralize it with 0.1 normal sodium hydroxide using phenolphthalein using 0.5 ml. So the phenolphthalein we take is 0.5 ml. So why we are making use of neutralized ethanol? Because ethanol itself is having acidic, so it may also contribute to the acidity. So we are making use of neutralized ethanol. Okay, now add the neutralized alcohol to the flask containing milk fat sample and mix the contents of the flask. Then after adding the neutralized alcohol to the flask, then you mix the content of the flask. Now bring the mixture to boil, and while it is still hot, titrate with standardized 0.1 normal sodium hydroxide, shaking vigorously during the titration. So bring the moisture to boil, and while it is still hot, titrate with standardized 0.1 normal sodium hydroxide, shaking vigorously during the titration. Now the end point of the titration is reached when the addition of single term produces slight but definite color persist change, that is persisting for at least 15 seconds. So when you do the titration, so end point will be pink in color, because we are adding sodium hydroxide, and phenolphthalein is having the pink color attains the pink color in basic conditions. So end point will be indicating by a pink color that persists for 15 seconds. Now, free fatty acid is expressed as percentage of free fatty acid in the sample, calculated as oleic acid. So this is the formula. T is the volume of 0.1 normal alkali required for titration in ml, and W is the mass in gram of the milk fat taken. So this is coming from the we can drive it by easily by the formula N1 V1 equal to N2 V2. So here in the one side we are taking the oleic acid, and the other side we are taking the NaOH. So here normality of NaOH into total volume the NaOH which is obtained, since V1 since we are taking the weight of the sample, that sample we are taking in grams, so here we will take dW. So N1 equal to this much. Now N1 is the number of gram equivalents of solute present in 1 liter of solution, this we know. So N2 V2 divided by W. Now since we have to calculate in percentage, so gram per 100 gram is nothing but the percentage. So if we take V instead of VML, we take 100 here, so this will go, this will 10, and equivalent weight of oleic acid if we take, it is 280 gram, 282 gram. So molecular weight of oleic acid is 282. Now if you put all the value, that is WB will come, that is the percentage oleic acid, is equal to your N2 will be there, V2 will be there, and divided by W will be there, and 282 divided by 10, 28.2. Now if you put the value of normality also of NaOH, then we'll have 2.82, because 28.2 into 0.1 will be 2.82 into V2 titer value upon my W, and this is same as this, so hence derived. So this way we can derive the formula also. Okay, now free fatty acid as per oleic acid as per FSSAI should be not be more than 2%. Now the recent standard of FSSAI that free fatty acid expressed as percentage oleic acid should not be more than 2%. Okay, so in this way we can can determine the free fatty acid content in ghee. So again repeating, 10 gram of milk fat sample into 50 ml conical flask, then you add you take 50 ml ethanol in another conical flask, and then when that boiling starts and then temperature is about 75 degrees Celsius, 70 degrees Celsius, you neutralize it, and then add the neutralized alcohol to the flask while you mix the content of the flask, and then when the mixing is done, again you boil it, and then under hold at a condition you titrate it until the pink color endpoint. But titrate you are getting, you put in the formula, you will have the free fatty acid content, and FSSAI it's probably maximum 2%. Okay, so this way we are determining the free fatty acid content of the any fat sample, oil sample, or ghee. Thank you.